Welcome. You have found a quiet space, a sanctuary from the noise. We are about to begin a journey together, drifting through the stillness of the cosmos. Before we set sail, if you find comfort here and wish to return to this place of calm reflection, you are warmly invited to subscribe. There are no bells or jarring alerts. It is just a gentle signal ensuring you can always find your way back to this quiet harbour. We are glad you are here. Now take a slow deep breath. Let the world outside fade. Let us begin. It begins with the quiet. The sounds of the day, the rushing and the lists have softened. They are fading. There is just the stillness. Perhaps you can feel the cool air on your skin, a sense of the world holding its breath. And as you settle in, as you let go, you can look up. There it is, the night sky. It is not a ceiling painted black. It is a depth. It is an opening. It is an invitation to drift. It stretches out a dark, soft velvet, and scattered across it are tiny patient lights, each one a question, each one a story. This is the oldest map we have ever known. It is a map of where we are and a map of everything we have ever wondered about. It asks nothing of you, only that you look, only that you breathe and allow your mind to float. There is a light that is more familiar than any other. Our silent neighbour, the moon. It hangs in the darkness, serene, bathing the world in a soft silver light. It is a comforting presence. We look up and we see that same familiar face we feel and known. It is our constant companion. But it is not just a light. It is not just a rock. It is a diary. It is the Earth's memory written in dust and craters. The moon has no air to blow the past away, no rain to wash its surface clean. Every mark, every scar from impacts that happened billions of years ago is still there. It holds the history of our own beginning. It has watched the Earth change from a world of fire to a world of water, and now to a world of us. It pulls on our oceans, creating the rhythm of the tides. It is our silent, faithful witness circling us, always circling. Let us drift away from that comforting light. Let your mind pull back further and further until our Earth is just a beautiful marble of blue and white and green. We see it now not alone, but as part of a family of worlds all held together by the gentle, invisible pull of the sun. This is our solar system. This is our home. Let us take a quiet journey. We drift first toward the centre, toward the Sun, to the closest sibling Mercury. It is a world of scorched solitude, a tiny, fast-moving world baked by the sun's unfiltered blaze on one side, yet frozen in the shadows that never see the light. It lives its life in a hurry, a silent, blasted piece of iron and rock. We pull back to the next, Venus. From here it is a jewel, the brightest light in our morning or evening sky. A world of exquisite veiled beauty. It is wrapped in thick, pale yellow clouds that hide its surface. And beneath those clouds is a furnace, a place of crushing pressure and impossible heat. It is a beautiful mystery, but one we must admire from afar. We pass our own blue home and move outward to the red dream, Mars. It feels familiar. It has canyons and dried up riverbeds and polar ice caps. It is a world that had a story of water, a story of a warmer, wetter past. Now it is cold and the air is thin. It is the colour of rust and longing. We look at Mars and we wonder if we are looking at a memory or a future. We must travel much further now past a belt of scattered rock and dust, and there we see the giant, Jupiter. It is not a world you could stand on. It is a world of gas, a colossal swirling ocean of clouds. It is the protector of the family. Its immense gravity pulls in comets and asteroids that might otherwise harm the inner worlds, shielding us. We see its great red spot, a storm that has raged for centuries, a storm bigger than our entire planet. It is a king, majestic and silent. And then, perhaps the most breathtaking sight of all, Saturn. It is not just a planet, it is a work of art. A masterpiece of gravity. Those rings. They look solid like a halo, but they are not. They are a river. A shimmering river of countless tiny pieces of ice and rock, each one in its own perfect orbit catching the sunlight. There is nothing else like it. It is a world of impossible quiet, quiet elegance. We keep going. We drift past the faint cold light of Uranus and Neptune, the ice giants blue and distant spinning slowly in the deep dark. We are leaving our neighbourhood now. We are crossing the frontier. We pass through a scattered ring of icy objects, leftover pieces from the birth of our system. This is the Kuiper Belt. The distant world of Pluto is here, a tiny king in a realm of ice. But we do not stop. We keep drifting We are now in the deep dark. The sun is just a star, now the brightest one, but still just a star. We are in a vast, cold emptiness, or is it? We are drifting through a ghostly sphere of trillions of comets barely held by the sun's fading gravity. This is the Oort cloud. This is the true edge of our solar system. The distances here are so vast that measuring them in miles or kilometers feels meaningless. The numbers become too large. We need a new measure, a measure of patience. We call it a light year. It is the distance that light, the fastest thing in the universe, travels in one full year. It is an immense journey, nearly 6 trillion miles. It is a number so large it's hard to hold in your mind. But think of it not as a number. Think of it as a measure of time and of solitude. It is the universe telling us to be patient. It is the universe showing us that even the nearest lights are very, very far away. And we are just beginning our journey. We are floating in the deep, quiet dark, far from home. The sun is now just one star among many, a single bright point of light. But we are not in an empty void. Look around. We are surrounded by other lights, countless lights. They are everywhere. Some are near, some are unimaginably far. And if you are on Earth on a clear dark night far from the lights of cities, you can see a band, a smear of light, a river of faint milky cloud that stretches from one horizon to the other. Our ancestors saw it. They gave it names, the celestial river, the backbone of the night. We call it the Milky Way. It looks like a cloud, but it is not. It is an illusion of perspective. Imagine you are a single grain of sand on the edge of a vast flat beach. When you look along the beach, you see a dense, crowded band of countless other grains of sand. But when you look up or down, you see only a few. That is what we are seeing. We are inside a vast, flat city of stars, a disk. When we look up or down out of the disk, the sky is dark with only a few stars. But when we look toward the center of the disk, we see that beautiful crowded river of light. We are looking into the heart of our own home. Let us pull back, further and further, leave our solar system far behind, travel for thousands and then tens of thousands of light years. Now we can see it, our home, our galaxy. It is a breathtaking sight. It is a spinning, luminous spiral, a pinwheel of light in the velvet darkness. This is our city, a city of not thousands, not millions, but hundreds of billions of stars. Look at its shape. See the great sweeping arms. These are the spiral arms. They are like rivers of creation flowing through the city. They are where the dust and gas are thickest. This is where new stars are being born right now. They are full of bright young blue stars, hot and brilliant, lighting up the clouds that formed them. Our sun does not live in one of these busy, bright arms. We live in a quieter, calmer neighborhood, a smaller spur, a place where life can have the peace to begin. And look toward the center. It is not flat. It is a glowing golden sphere of light. This is the central bulge. This is the old heart of the city. Here billions of stars are crowded together, ancient stars, most of them old and yellow and red. They have been circling each other for eons. The light here is not the sharp blue of the arms, but a deep, warm, ancient glow. And surrounding it all, like a vast ghostly sphere, is something else. The halo. You can barely see it. It is a vast, faint bubble of very old stars and ancient clusters like scattered snow globes, each one holding 100,000 stars all moving together. This is the galaxy's attic. It holds the oldest members of our city, the first ones to form the silent witnesses to our galaxy's entire history. This is our home, this disk, this bulge, this halo, all of it. A single self-contained island of light. Let us choose one of those lights, just one, a single star, and let us tell its story. For in its story, we find our own. The story does not begin with light, it begins with darkness. It begins in one of those spiral arms in a vast, cold, dark cloud of dust and gas. A nebula, a celestial nursery. It is a place of immense quiet and potential. For thousands, perhaps millions of years, this cloud just drifts. But gravity is patient. It gently pulls. A few particles of dust find each other, then a few more. A tiny knot begins to form in the cold dark, a seed. As more and more gas and dust fall into this seed, it grows, it gets denser, and as it gets squeezed by its own weight, it gets hotter. It's not a star yet. It is a protostar, a star in waiting. It is a glowing ember in the heart of the dark cloud. It keeps pulling in more material, getting heavier, hotter, and denser at its core, until one moment, a threshold is crossed. The pressure and temperature at the very center become so extreme that something new happens. A new kind of fire is lit. It is not a fog we know on Earth. It is fusion. The atoms of hydrogen at the core are crushed together so violently that they merge and they become helium. And in that tiny, tiny change, a spectacular amount of energy is released. A star is born. In that moment, a wind of light and energy rushes out, blasting away the cocoon of dust that surrounded it. The star's light shines free for the first time. Now begins the long, stable, quiet part of its life, its adulthood. For billions of years, it will just sit in perfect balance. The inward crush of its own gravity and the outward push of the fusion in its core, holding each other in a perfect steady dance. Our sun is in this phase right now, a patient fire, a giver of life, a steady beacon burning hydrogen into helium second after second for 10 billion years. But nothing lasts forever. Eventually, the hydrogen fuel in the star's core begins to run out. The fire falters, the balance is broken, gravity begins to win, the core contracts, and as it does, it gets even hotter. This new intense heat pushes the star's outer layers out. The star begins to swell, it swells and it cools and it turns a deep, beautiful red. It becomes a red giant. It is a star in its old age, a beautiful final bloom so large it might swallow the very planets that grew up around it. And then the end comes. The path it takes depends on its size. If the star was like our sun, its end is quiet. It is gentle. Its outer layers, those red swollen clouds, just drift away. They float off into space, creating one of the most beautiful sights in the universe. A planetary nebula, a ghostly glowing ring of iridescent colour. It is the star returning its breath to the cosmos. And at the centre, the core that was left behind remains. It is no longer a star, it is an ember, a white dwarf, that it is the dead heart of the star, incredibly hot, incredibly dense. A single object the size of Earth that weighs as much as the sun no longer makes new heat. It just sits, and over trillions of years, it will slowly fade to black. A diamond in the dark, a memory of a life. But if the star was massive 8, 10, 20 times bigger than our sun, its death is not quiet. It is the most violent event in the universe. When its fuel runs out, the core collapses. It doesn't contract slowly. It collapses in an instant. The entire star falls in on itself at a quarter of the speed of light. It slams into its own iron heart and rebounds in a colossal, unimaginable explosion. A supernova. In one moment, this single star can outshine all the other 100 billion stars in the galaxy combined. It is a blast of light and energy so powerful it can be seen across the universe. But this explosion is not just an end, it is a creation. In the stable life of a star, it can only make elements like helium, carbon, and oxygen. But in the fire and fury of that supernova explosion, all the other elements are forged. The gold in a ring, the silver in a coin, the silicon in the sand, and the calcium in your bones, the iron in your blood, the oxygen you are breathing right now, all of it. It was all created, forged in the heart of a massive star that lived and died billions of years ago. The explosion scattered those new elements across the galaxy, seeding the clouds that would one day form a new star and new planets, and on one of those planets, life. You are not just living in the universe, you are the universe, you're stardust. You are the legacy of a star that died so that you could be here. You are the galaxy recycled. And where do all these stars, these clouds, these stories, where do they all move? Let us journey now to the very centre of that golden glowing bulge, the heart of our city. Here the stars are moving incredibly fast. They are swarming like bees orbiting something we cannot see. It's a point of complete darkness, yet it holds the entire galaxy in its hand. We call it Sagittarius A star. It is our galaxy's supermassive black hole. When you hear that word black hole, it is easy to imagine a monster, a cosmic vacuum cleaner pulling everything in. But that is not what it is. From this far away, its gravity is just like anything else of its mass. It is not a predator. It is an anchor. It is a point of stillness, a silent, invisible centre of gravity around which our entire city of light spins. It is the conductor of this grand celestial orchestra. It is the calm centre of this beautiful, swirling dance. Every star you have ever seen, every nebula, every story including our own sun and our own small blue world is in orbit. All of us together circling this once invisible heart. This is our Milky Way, our city, our home, and we are a part of its grand, beautiful turning. We are floating looking at our home, our galaxy, our city of stars, the Milky Way, a spinning island of light, For so long we thought this island was all there was. We thought the few fuzzy, faint clouds we saw in our telescopes were just that. Clouds, nests for new stars here inside our own city. But in the early 20th century, an astronomer named Edwin Hubble looked at one of these clouds, one of these spiral nebulae, and he saw a star inside it. A special kind of star that pulsed one that allowed him to measure its true distance. And he found it was not a few thousand light years away, it was millions. It was not a cloud, it was another city. An entire, separate, vast island of stars, just like ours. In that moment the universe broke open. Our one island became one of many. Our city became one in a vast cosmic archipelago. We were not alone. Look, there, the closest great city to our own. You can see it on a dark night even without a telescope. A faint oval smudge of light in the constellation of the same name, Andromeda. It is our sister galaxy. It is larger than our own, perhaps 1 trillion stars to our few hundred billion. It is a beautiful, magnificent spiral. And we are looking at it, not as it is now, but as it was 2.5 million years ago. That is how long its light has had to travel to reach us. And as we watch it, it is not moving away. It is coming closer. Gravity across that immense dark is pulling our two great cities together in a slow, inexorable cosmic dance. Billions of years from now, our two galaxies will meet. They will not crash, they will merge, they will pass through each other, like two ghosts, their stars rarely ever hitting, but their gravity will weave them together into one new, even larger galaxy. It is not an end, it is a new beginning. And Andromeda is just one. We look further with our great telescopes and we see them everywhere. Billions, perhaps trillions of them. And they are not all the same. The universe is a garden of infinite variety. We see other great spirals like ours and Andromeda with beautiful, graceful arms where new stars are being born. We also see ellipticals. These are different. They are not flat disks, they are vast, round or egg-shaped clouds of light. They are golden, filled with old red and yellow stars. Their star-making days are long over. They are the ancient, settled, quiet cities of the cosmos. And then we see irregulars. They have no shape at all. They are chaotic, beautiful, messy splashes of light. Some are this way because they are young, still figuring out their form. Others are this way because they have collided with a neighbour, their graceful shapes torn apart in a dance of gravity. Each faint smear of light in a telescope's deep gaze, each one is a home, an island of billions of stars and perhaps of billions of worlds. So we have these islands, these cities of light. Are they just scattered at random like seeds thrown into the dark? For a long time we thought so, but let us pull back again. Further, so far that our Milky Way and even Andromeda are just tiny points of light, we pull back hundreds of milliards of light years. And now we see it, the true map. The galaxies are not random. There is a structure, a pattern, the grandest, largest structure in all of existence. It looks alive. It looks like the neurons in a brain. It looks like the delicate threads of a spider's web glowing in the dark. We call it the cosmic web. The universe on its grandest scale is a network, a glowing tapestry of matter. See the bright threads that connect everything. These are the filaments. They are vast cosmic rivers of dark matter and gas, and along these rivers the galaxies are strung like pearls on a necklace. These are the highways of the universe. Our Milky Way. Our little city lives on one of these quiet glowing threads, and see where the threads cross. Where they meet, these are the great intersection, bright, dense, brilliant knots of light. These are the clusters. These are the great cities of the web. Here not one but thousands of galaxies are all held together by their shared gravity, swarming around each other in a beautiful chaotic dance. And see the spaces in between the vast dark empty regions. These are the voids, the great cosmic oceans of almost nothing. A galaxy might drift alone in one of these voids for its entire life in a profound deep solitude. This is the universe we live in. Not a random scatter of stars, but a living, breathing, connected structure of filaments, clusters and voids, an endless, beautiful web. And what is this web doing? Is it still? Is it sitting frozen in the dark? Edwin Hubble, the same man who found the other islands, found the next clue. He looked at the light from these distant galaxies, and he noticed something strange. When an object moves away from you, the sound it makes is stretched. The pitch drops. Think of a siren, its high wail dropping to a low moan as it passes you and rushes away. The same thing happens to light. If a galaxy is moving away from us, the light it emits is stretched, and when light is stretched, it becomes redder. We call this redshift. Hubble looked at the light from almost every galaxy, and almost every single one was redshifted. They're all moving away from us, and he found a pattern. The farther away a galaxy is, the faster it is moving away. Now, this can make you feel a little strange. Does this mean we are at the center of everything? Is the entire universe running away from us? No, this is the part that is so hard to picture, but there is a simple way to feel it. Imagine a loaf of raisin bread dough, not yet baked. You're sitting on one of the raisins. Now you put the loaf in the oven. The dough begins to rise. It expands. What do you see from your raisin? The raisin next to you moves away a little bit. The raisin on the other side of the loaf moves away much faster. The dough itself is expanding and is carrying all the raisins along with it. From the perspective of any raisin in the loaf, all the other raisins would look like they are rushing away. We are on a raisin. Our galaxy is a raisin. The universe is the dough. It is space itself that is expanding. Space is breathing. It is a slow cosmic exhalation that has been happening for billions of years, carrying the great islands of light, the galaxies, further and further apart. This is a profound realization, and it leads to a profound question. If everything is moving apart, what happens if we rewind time? If we play the movie of the universe backward, all of those galaxies, all those islands, all that matter would rush on together. The web would collapse, the filaments would merge, the clusters would become one. The universe we see would get smaller and smaller and hotter and denser, until eventually all of it, everything we can see, all the trillions of galaxies, all the stars, all the energy, all of it was crushed together into a space smaller than a single atom, a state of impossible, unimaginable energy, heat and density. This is the beginning, the moment we call the Big Bang. It was not an explosion in space, it was the sudden rapid expansion of space itself. The birth of space, the birth of time, the beginning of the dough rising. But that is a story. Is there any proof? Is there an echo left over from that first fiery moment? Yes. In its first moments, the universe was not dark. It was a brilliant white-hot opaque fog of plasma, hotter than the core of any star. Light was trapped inside this fog, bouncing around, unable to travel free. But the universe was expanding, and as it expanded, it cooled. For about 380,000 years it cooled, until it reached a magic temperature. Suddenly it was cool enough for the first atoms to form. The fog cleared. The universe became transparent, and the light that was trapped was set free. In that instant, the first light of creation, the sunrise of the universe, flooded all of space. That light has been travelling ever since, for 13.8 billion years, and as the universe has expanded, that light has been stretched, just like the light from the distant galaxies. It was once a brilliant white-hot light, but it has been stretched and stretched and stretched until it is no longer visible light. It is no longer heat. It's been stretched all the way down into microwaves, the same kind of energy used in a microwave oven or for radar. We can still see it. It is here, right now, all around us. No matter where we look in the sky, with a radio telescope we see it. It is coming from every direction at once. It is a faint, gentle cosmic glow. We call it the cosmic microwave background. It is the afterglow of creation. It is the oldest light in the universe. It is the echo of that first fiery moment. It is the faint fading hum of the Big Bang still filling every corner of reality. It is bathing our planet, our homes, and you right now. You are floating in the memory of the beginning. You are listening to the eternal quiet lullaby of the cosmos. We have journeyed backward in time. We have watched the great cosmic web of galaxies, the filaments and voids all rush together. We have rewound time past the birth of the first stars back to that moment when the universe was a brilliant hot fog. We are listening to the echo of that moment, the cosmic microwave background, the first light set free. Let us keep going, let us push our minds back further. Before that light was free, before the first atoms, we go back to when the universe was just 1 second old, a seething, turbulent sea of pure energy and exotic particles hotter and denser than anything we can imagine. We go back further, a millionth of a second, a billionth, a trillionth, and we arrive at a place where our physics, our understanding begins to falter. We have rewound the movie all the way back, and we stand at the edge of a question, the ultimate question. If everything, all the matter, all the energy, all of space itself, came from this one single infinitely tiny point, where did that come from? What was before the beginning? We are confronted by the mystery of nothing. When we think of nothing, our minds picture an empty room, a silent, dark, empty space. No particles, no energy, no movement, just absence. We think of a vacuum as being truly perfectly empty, but that is not how nature works, not at the fundamental level. In physics, in the strange and beautiful rules of quantum mechanics, what we call a vacuum is not empty at all. It is not still, it is not silent. It is the restless sea, a sea that never ever sleeps. This is a strange idea. It is counterintuitive. If you take a box, a perfect theoretical box, and you take everything out, I mean everything. You remove every atom, you pump out every particle of light, every photon, you cool it down to absolute zero, removing all heat. You would think you would be left with nothing, but you are not. You are left with potential. You are left with what we call quantum fields. These fields are the fundamental fabric of reality. There is a field for light, a field for electrons, a field for everything. And these fields, even in their lowest possible energy state, are still trembling. They are alive with a tiny, spontaneous, constant fluctuation. This is not a guess, it's a fundamental rule of the universe. The rule is called the Heisenberg uncertainty principle. It is a simple-sounding rule, but its consequences are profound. It says that you cannot know everything about a system perfectly all at once. You cannot know the exact energy of a region of space for an exact duration of time. And this tiny bit of uncertainty, this fuzziness to reality, acts like a loophole. It allows the universe to borrow energy from nowhere for a very, very short amount of time. And in that moment, in that tiny flicker of borrowed time, a particle and its opposite, an antiparticle, can flash into existence. They appear from nothing, literally from the fields. They look around, and then an instant later they find each other and they annihilate. They vanish back into the nothing they came from. They are called virtual particles. This is happening right now, everywhere, in the space between you and the sound, in the deep, cold, empty space between galaxies, in the room around you. This empty space is actually a seething, bubbling quantum foam. A pot of boiling water, but instead of steam, it is particles of reality appearing and disappearing faster than we can comprehend. You might be thinking, this sounds like a story, a metaphor. How could we possibly know this? We know because we have measured it. We have seen the effects of this nothing. There is a famous experiment called the Casimir effect. Imagine you take two perfectly flat, perfectly smooth metal plates, mirrors, and you bring them into a perfect vacuum where there is nothing. You bring them incredibly close together. So close, they're only a few nanometers apart, just a few atoms wide. According to our old ideas of nothing should happen, they are just two plates in an empty void. But something does happen. A real measurable force pushes them together. Why? Because of that quantum foam, because of those virtual particles. It turns out that in the infinite empty space outside the plates, all kinds of virtual waves and particles can flicker into existence. Big ones, small ones, every kind. But in the tiny, tiny microscopic gap between the plates, only the very smallest waves can fit. There are more fluctuations, more waves on the outside than on the inside. This creates a pressure, a real physical pressure from the vacuum. The nothing on the outside is pushing harder than the nothing on the inside, and the plates are pushed together. Nothing is creating a measurable force. That is astonishing. The emptiness around us is not empty. It is full of a hidden restless energy. And this discovery changes everything. Because this energy, this vacuum energy, it doesn't just work on tiny plates in a lab, it works on the entire universe. Let's go back to our expanding cosmos. We know the galaxies are moving apart, but in the late 1990s, we discovered something shocking. We thought the expansion was slowing down, pulled back by the gravity of all the galaxies. It is not. It is speeding up. The galaxies are moving away from us faster and faster and faster. Something is pushing. Something is stretching space itself, overwhelming gravity on the largest scales. We gave this mysterious push a name. We called it dark energy. We did not know what it was, but it is the most powerful force in the cosmos, making up more than 70% of everything that exists. And our best explanation, the most profound and the most simple explanation, is that dark energy might just be the energy of the vacuum itself, the energy of that restless, foaming quantum sea, that nothing. That bubbling foam of virtual particles is not just a tiny background effect. It is the single most powerful thing in the universe. It is the engine that is pushing our entire cosmos apart. It is shaping our future. And this leads us to the final most mind-bending idea. If the energy of the vacuum is powerful enough to push a universe apart, is it powerful enough to create one? Let us go back to that question. What came before the beginning? The old answer was a single hot, dense point, but the new answer is even stranger. What if there was no single point? What if before the beginning there was only the vacuum, only that restless infinite sea of potential, an eternal timeless quantum foam? And what if in that endless bubbling sea a fluctuation happened? Not just a small one that vanished in an instant, but a fluctuation that was different. What if a tiny patch of that vacuum, by pure random quantum chance, fluctuated into a state of incredibly high energy? And what if that tiny high energy bubble of nothing became unstable? This is the theory we call inflation. It suggests that our entire universe began as one of these fluctuations, a bubble of false high energy vacuum far, far smaller than a single atom. And in the very first fraction of a second, this bubble did not just expand, it inflated. It doubled in size, and doubled again and again, faster and faster and faster, an exponential explosive expansion of space itself. It grew from a quantum twitch to the size of a marble in a trillionth of a second. It did not expand into space, it became space. And then, just as suddenly, the inflation stopped. The bubble cooled. That immense false energy of the vacuum had to go somewhere. And it did. It decayed and transformed. That energy, the energy of nothing, turned into everything. It became that first hot, dense fog of plasma. It became all the matter, all the energy, all the light, all the particles that would one day become the galaxies, the stars, the planet, and you. The Big Bang was not the beginning. The Big Bang was the afterglow. It was the moment the inflation ended and the hot, familiar universe was born from the energy of the vacuum. And we can see the proof. Remember that echo, the cosmic microwave background, is not perfectly smooth. It has tiny faint ripples, small spots that are just a little bit warmer or a little bit colder. Where did those ripples come from? They are the stretch marks of creation. They are the original microscopic quantum fluctuations in that first tiny bubble of vacuum stretched by that incredible inflation to the size of the entire observable universe. When you look at a map of that ancient light, you are seeing a photograph. You are seeing a giant cosmic picture of the quantum foam from which we were born. So when we ask, what is the origin of everything? The answer is perhaps that it all came from nothing, but a nothing that is not nothing at all, a nothing that is everything. The vacuum is not the absence of reality. It is reality. It is the foundation. It is the ocean. And everything we see, everything we know, everything we are just a wave. A beautiful, complex, temporary wave on the surface of that eternal restless sea. Our journey into the vacuum has until now focused on what it is. We have seen that it is not a void, but a seething foam of quantum potential, a reservoir of virtual particles and the source of mysterious dark energy. Now we turn to the most profound and strangest consequences of this discovery. If the vacuum is not nothing, then what does that make something? We are forced to reconsider the very nature of reality, the uniqueness of our universe and the foundation of our own consciousness. The most fundamental shift in perspective is this. The vacuum is the true reality, what we perceive as matter, the solid floor beneath our feet, the air we breathe. The stars in the sky is not the primary substance of the cosmos. Instead, all particles, all fields, all of an electron's charge and a photon's light are merely ripples on the surface of this deep underlying ocean. Think of a perfectly still infinite ocean. This is the vacuum in its lowest energy state, its ground state. If you tap the surface, a wave appears. This wave can travel, it has energy, and it has specific properties. This wave is what we call a particle. An electron is just a persistent, stable excitation, a wave in the electron field that fills the vacuum. A photon is a wave in the electromagnetic field. Our entire reality, all the stuff of the universe, is just a complex symphony of these different waves or excitations playing out on the fundamental medium of the vacuum. This changes everything. The vacuum is not just the passive empty stage on which the play of reality unfolds. It is also the actor. Its properties define the script. The energy of the vacuum, the cosmological constant, dictates how the entire universe expands. The way the vacuum breaks symmetries dictates which particles have mass and which do not. The vacuum's fluctuations are not just a minor microscopic effect, they are the engine of creation and the ultimate foundation of all existence. Nowhere is the power of the vacuum more evident or more strange than at the edge of a black hole. These cosmic monsters where gravity is so strong that not even light can escape represent the ultimate clash between gravity and quantum mechanics, and it is the vacuum that wages war against them. Stephen Hawking's most famous discovery was that black holes are not in fact black. They must radiate energy and slowly evaporate over time. This process, known as Hawking radiation, is a direct consequence of the quantum vacuum. Here is a simplified picture of how it works. The vacuum, as we know, is filled with virtual particle-antiparticle pairs that constantly pop into existence and annihilate each other, in a tiny fraction of a second borrowing energy from the vacuum and paying it back before the universe notices. But right at the event horizon, the point of no return of a black hole, something different can happen. A pair of virtual particles can pop into existence, and just as they are about to annihilate, one particle might fall into the black hole, while its partner escapes into space. From an outsider's perspective, this escaping particle looks like radiation being emitted from the black hole. To conserve energy, the particle that fell in must be seen as having negative energy. This negative energy is subtracted from the black hole's total mass. Over and over, for trillions upon trillions of years, this process repeats. A virtual pair is born. One falls in adding negative energy, and one escapes becoming real radiation. The vacuum is in effect eating away at the black hole, slowly draining it of its mass, until after an unimaginable length of time the black hole evaporates completely in a final flash of light. This evaporation, however, creates a puzzle so deep it threatens the foundations of physics, the information paradox. A core rule of quantum mechanics is that information can never be destroyed. The universe must in principle keep a perfect record of everything that happens. If you burn a book, the information in it is not truly gone. It is just scrambled and encoded in the smoke, the ash and the heat. A supercomputer could in theory reconstruct the book. But when a black hole evaporates, what happens to the information of all the stars and particles that fell into it? Hawking's original calculation suggested that the radiation coming out is purely thermal. It's random and contains no information about what fell in. If the black hole disappears and the information is not in the radiation, then that information is permanently lost, violating the most sacred law of quantum physics. So where is the information? Is it lost, or is it somehow stored in the vacuum itself? This is the frontier of theoretical physics. The emerging consensus is that the information must escape. It might be subtly encoded in the quantum properties of the escaping Hawking radiation, or perhaps it is stored on the two-dimensional event horizon itself, like data on a cosmic hard drive, an idea known as the holographic principle. In this view, the vacuum and the structure of space-time itself are the ultimate information storage medium, holding the story of everything that has ever been. The vacuum is not just the end state of black holes, it is the beginning of entire universes. This idea comes from the theory of cosmic inflation, our best model for the first fraction of a second of the Big Bang. The theory suggests that our universe began as a tiny, dense point. But this point was not in the stable, low-energy vacuum we know today. It was in a very different state, a high-energy, unstable, false vacuum. This false vacuum state had a bizarre property. It possessed a massive amount of energy that acted like anti-gravity, pushing space apart at a truly exponential rate. In a fraction of a second, a region smaller than an atom was stretched to be larger than a galaxy. This period of inflation stopped when the false vacuum finally decayed, like a ball rolling down a hill into the stable, low-energy true vacuum we inhabit today. The enormous energy stored in that false vacuum was released, transforming into the flood of matter and radiation that we call the Big Bang. But here is the key idea which leads directly to the multiverse. What if this inflation never stopped? This is the theory of eternal inflation. Imagine the false vacuum not as a ball, but as a vast, infinite sea that is eternally expanding. In some random spots, quantum fluctuations cause a small region to decay as our universe did. This decay creates a bubble of true vacuum. Inside this bubble, a Big Bang happens, stars form, and a universe like ours is born. But the sea around the bubble is still the false vacuum, and it is still inflating, expanding faster than the bubble walls can grow. This rapidly expanding sea creates more and more space, providing more and more opportunities for new bubbles to form, each born from its own quantum vacuum fluctuation. Our entire vast observable universe, with its hundreds of billions of galaxies, would just one bubble in an infinite bubbling sea of foam. We live in a multiverse, an endless collection of other universes, each one a bubble nucleated from the quantum vacuum, each potentially with different histories and perhaps different laws of physics. This sea of foam model sets the stage for one of the most staggering ideas in science, the landscape of laws. If new bubble universes are constantly being born, will they all be like ours? String theory. A leading candidate for a theory of everything suggests the answer is no. String theory requires extra spatial dimensions beyond the three we see curled up into tiny complex shapes. The precise shape size and configuration of these extra dimensions determine the fundamental laws of physics for that universe. They set the energy of the vacuum, the mass of the electron, and the strength of gravity. The theory doesn't predict one single way for these dimensions to be. Instead, it suggests a colossal number of different stable configurations, perhaps 10 to the power of 500 $10, $500 different possibilities. Each possibility is a different type of stable vacuum, and each vacuum would have its own unique set of physical laws. This vast menu of possible physics is called the string theory landscape. When a new bubble universe is born in the eternal sea of foam, it lands on one of these possible vacuum states at random. In one universe, gravity might be 1,000,000 times stronger, crushing everything into black holes. In another, the electromagnetic force might be too weak for atoms to form. In another, the vacuum energy itself might be so high that the universe rips itself apart in an instant. The vast majority of these universes would be sterile, empty, and lifeless. This leads to a beautiful, if unsettling, solution to one of physics' greatest mysteries. Why are the laws of our universe so perfectly fine-tuned for the existence of life? If the strength of gravity or the mass of a proton were different by even a tiny fraction, stars, planets, and chemistry would be impossible. The answer is the anthropic principle. We don't live in a universe that was designed for us. Instead, we live in one of the vanishingly rare bubbles in the multiverse, where the laws just happen to be right. We find ourselves in this specific universe for the same reason we find ourselves on a life-bearing planet. We're here because this is one of the few places where we could be. All those other $10, $500 plus universes exist, but there is no one in them to wonder why. Our existence is a form of selection bias, selecting the one bubble from the infinite foam that had the right ingredients for consciousness to emerge. This exploration of infinite possibilities brings us to our final and most disturbing puzzle, the Boltzmann brain. This is a dark philosophical paradox that arises directly from the idea of random vacuum fluctuations. Here is the thought experiment. If our universe exists for a truly astronomical, perhaps infinite amount of time, it will eventually settle into a cold, dark, maximum entropy state known as heat death. It will be a thin, uniform, boring soup of particles, but even in this dead universe, the quantum vacuum will still be fluctuating. Given an infinite amount of time, everything that is physically possible will eventually happen as a random fluctuation. A new Big Bang could fluctuate into existence, a spaceship could fluctuate into existence, and far more easily a single conscious human brain could fluctuate into existence, complete with a full set of false memories. This hypothetical disembodied mind, randomly assembled from the vacuum's chaos, is the Boltzmann brain. Now here is the paradox, which is more statistically likely. The complex, highly ordered, low-entropy Big Bang, followed by 13.8 billion years of precise evolution to create a universe, a galaxy, a planet, and eventually your brain. A single isolated Boltzmann brain randomly fluctuating into existence in an old, dead universe, which believes it is you and has a complete set of false memories of a life that never happened. The terrifying answer is that in many cosmological models, the Boltzmann brain is vastly more probable. It is far easier to randomly assemble one small complex object called a brain than it is to randomly assemble an entire complex low-entropy universe. This is a critical problem for physics. If a scientific theory predicts that the vast majority of observers in the universe are not real beings who evolved, but are just these random, fleeting brains with false memories, then that theory has a fatal flaw. It predicts that we are almost certainly wrong about everything. Our memories are false, our scientific observations are illusions, and the very laws of physics we use to make the prediction are just random data hardwired into our fluctuated minds. It is a theory that eats itself. It is self-undermining. Cosmologists and philosophers are forced to find a way out of this paradox. A theory is only considered viable if it predicts that normal observers like us vastly outnumber the random Boltzmann brains. This might mean our universe is structured in a way that avoids an infinite fluctuating future. But perhaps the most profound escape is to reconsider what consciousness is. A Boltzmann brain is a random state. It flashes into existence and then dissolves. It has no past and no future. Our consciousness, on the other hand, is a process. It is built on a consistent, stable relationship with our environment. We form memories because of the stable arrow of time, which itself is a product of our low-entropy Big Bang. Our thoughts are not random, they are correlated with a real history. Perhaps then a conscious observer cannot be a random state. Perhaps it requires a process, a history, and a stable low-entropy universe to evolve within. In this case, we are not Boltzmann brains, because that state of consciousness is not the same as our process of consciousness. Our existence, rooted in time and built by evolution, is fundamentally different, and we must hope infinitely more real than a momentary random thought in the dark. Our journey has taken us to the furthest reaches of space, to the beginning of time, and into the ghostly, shimmering reality of the quantum foam. We have confronted the idea of infinite universes and the strange paradoxes of our own consciousness. Now it is time to bring this journey home, back to the only place we truly know ourselves in this present moment. The grand cosmic story we have been exploring is not an abstract external thing. It is in the most literal sense our story. The atoms that make up your body, the calcium in your bones, the iron in your blood, the carbon that forms the basis of your cells were not created here on Earth. They are ancient travelers. They began as simple hydrogen and helium. The first elements formed in the moments after the Big Bang, when the universe first cooled enough for the vacuum's energy to condense into matter. These first atoms then gathered into the first giant stars. For millions of years they were cooked in the unimaginable heat and pressure of those stellar furnaces, fusing into the heavier elements that make life possible. When those stars finally died in spectacular supernova explosions, they scattered this precious cargo across the galaxy. This stardust, this ash of dead stars, drifted through the void for eons, eventually mixing with another cloud of gas and dust which collapsed under gravity to form our sun, our planet, and eventually you. You are not separate from the cosmos. You are the cosmos. You are the living, breathing, thinking legacy of that first vacuum fluctuation. We are, as the saying goes, stardust that has woken up. We are the universe's way of observing and contemplating itself. This leads us to the mystery of our own awareness. If we are the universe becoming self-aware, what is this consciousness? Let us return to the idea of the vacuum as the ultimate ground of potential. It is the infinite unwritten software from which all hardware, all particles, fields, and structures emerges. A particle is one expression of that potential. A galaxy is a vast, complex expression. Perhaps consciousness is the most remarkable expression of all. It is not a thing but a process, a way for that underlying potential to become aware of its own creations. We are the mirror in which the vacuum can, for a brief moment, see its own reflection. Our minds are a tiny local ripple where the universe's potential for self-awareness is finally and beautifully realized. This perspective offers a profound comfort when we face the one truth that connects everything: impermanence. We have seen that even black holes evaporate, stars burn out, galaxies will drift apart. The universe itself will one day grow cold and dark. Our own lives are by comparison an impossibly brief flash of light. It is easy to feel that this temporary nature makes everything meaningless. But the meaning of a beautiful piece of music is not found in its permanence. We do not demand that the song play forever for it to be worthwhile. The meaning is found in the experience of listening in the notes as they pass. The song is beautiful because it has a beginning, a middle, and an end. Our lives are the same. We are the temporary, complex, self-aware patterns that the vacuum has produced. We are the wave that rises from the ocean, sees the sun, and returns to the deep. The meaning is not in lasting forever. The meaning is in the experience in this very moment of awareness. The fact that this moment is temporary is precisely what makes it precious. And so our journey ends where it began, in the quiet of the present. We can now connect the largest idea in the cosmos, the quantum vacuum, with the most intimate experience we possess, the stillness of our own mind, as we drift towards sleep. We often speak of emptying our minds. In meditation, we seek a quiet void between our thoughts. We associate this emptiness with peace, with rest. We have been taught by our journey that this emptiness is not nothing. The quantum vacuum, the ultimate void, is not a barren emptiness. It is the space of potential, the fertile ground of being, from which all of creation is born. Your mind is the same. The quiet stillness you feel when you close your eyes is not a nothing. It is the space of your potential. It is the peaceful, receptive ground from which your next thought, your next dream, and your next act of creativity will emerge. It is not an absence, but a presence. As you lie here, let go of the vastness of the multiverse and the fate of black holes. Bring your awareness back from the stars and anchor it in your own body. Feel the simple physical reality of the bed supporting you. Feel the weight of your arms and legs as they grow heavy and relaxed. Focus only on your breath, a simple gentle rhythm, an inhale and an exhale. Each breath is a reminder that you are here in this moment. Each exhale is an act of letting go, of releasing the day. You are a wave, a temporary beautiful pattern of matter and energy born from the cosmic ocean. And now it is time for the wave to return to the sea. It is time to let go and dissolve back into the deep, quiet and mysterious ocean of the subconscious, a sea of potential, just as vast and profound as the universe itself. Do not fear the emptiness of sleep. It is not an end. It is a return to the source. It is the fertile void. Let your thoughts fade. Let your body rest. Let yourself drift into the deep healing silence.